Hi, and welcome. In this video, we will go over home automation and IoT solution provided by Mimik. Let's look at the existing commercial over-the-shelf solution versus Mimik Edge Cloud technology. We will first look at the overall characteristics with the existing solution, and in this case study, we'll look at Google Home, also known as Nest Home. So we'll look at the Google Cloud first. Google Home IoT backend is where all the processing takes place. Firstly, any user with an IoT device must register to their account and profile. After successful registration, Google Cloud will create an ID service for the device or devices and issue them unique IDs. After this, Google Cloud now has knowledge of the device or devices. For example, device capabilities, how to discover it, how to connect to it, and how to communicate with it. Google Cloud sets, manages, and stores device policies and settings. Without this back end in the cloud, all IoT devices would be rendered unreachable by applications due to all communications having to go through the central cloud. Now we'll look at the IoT device. A general purpose use IoT thermostat, Nest IoT thermostat. All API requests are sent from Google Cloud on behalf of the application. Device frequently sends status updates to the cloud and serves correct data to the application. With no internet, this device will no longer be able to provide the cloud with any data. This device will only be accessible via physical interface, i.e. if it has a LCD display or any type of display, or hard buttons on the physical device. Now we'll look at the application on the smartphone. Application is pretty much a slave to the cloud and is only rendering data coming from what is fetched from the cloud. Application can only send requests to the cloud, has no visibility into IoT cluster. Let's look at the architectural drawbacks of using a cloud-centric approach like Google does. All of the user private data that is accumulated over the course of using Google Cloud is stored on the cloud. For a new age, data privacy aware user, this can be troublesome. Data can be sold or intruded upon at the discretion of Google Cloud. Now we'll look at the PubSub communication model that you see in the middle of the screen here, leading from the user local network to the cloud, home network to the cloud. Home internet is bombarded with requests and responses caused by PubSub model. This means a lot of traffic for the user's network. Anything that goes outbound to the cloud has the potential to being a data privacy risk. High potential point of failure for the entire system. There's a heavy reliance on the cloud is another high potential point of failure. For example, if the cloud goes into maintenance or you can't reach the cloud for some reason or reach the servers, then you're pretty much locked out. Mismanagement of account or becoming blacklisted by automatic processes in the cloud could possibly mean being locked out of entire home IoT cluster of devices. Account switching or renewal of an account will result in loss of all user data. For example, you have to reconfigure all of your IoT devices, pretty much reset them and reconnect them to your account to be able to access your IoT cluster of devices again. Latency is a big issue here as well. Consider this model for all your neighbors and their IoT cluster of devices. This puts a big strain on the cloud that results in slow response times that can only be overcome in most situations by paying either higher rates for internet or signing up for memberships provided by Google that prioritize your connection over someone that's using a free account, for example. With this model, and with everything that's been said, users participating in this solution will only receive limited control on IoT devices. I will talk about this a little more in future slides. Now we'll look at the Mimik approach and utilizing Edge Cloud. We'll look at the benefits from a network and data privacy perspective. In previous slides, we mentioned that everything takes place on the cloud. All the processing takes place there. All of the device knowledge is stored there. Cloud has to manage inbound requests from application and respond to both application and send user requests to IoT device or devices. All of this creates a massive strain on the cloud that result in a bad and limited experience for the user. With Mimik Home IoT solution, we utilize the Mimik edgeEngine and microservices to take huge load off of the cloud and do everything at the edge. With this architecture, a Mimik-enabled smart home application can utilize the smartphone's capabilities to directly communicate with devices in IoT cluster via a gateway-like device that can handle requests like a cloud and respond at the edge. With this solution, system only needs to be connected to the internet once to register devices and nodes to the backend. After that, there is no need for constant communication like we saw previously in the pub-sub model. Without internet, the whole system can operate like normal for a few months. This is achievable because all of the processing is now taking place at the edge, and there is no need to go to the cloud. Mimik edgeEngine and microservices allows the smart devices of today to be able to run and execute what was once ran in the cloud at the edge. With Mimik, user data is sent or stored, no user data is sent or stored on any cloud. All of that data is kept secure and encrypted at the edge. When communication with the central cloud is absolutely necessary, it only takes place during opportunistic times, and it does not happen very often. For example, during downtimes on the server when not a lot of people are connected. This usually means nighttime for normal people or people generally around. So not only does this solution take the strain off of the cloud, but it simultaneously adds more layers of security to user private data. Now let's look at the functionality differences between existing solution and Mimik Edge Cloud. So here we have a real setup that a colleague uses at their home with the Google Home application. We will scroll through this application to see what devices he has set up. So we see he has a couple of locks, a couple of displays, and some speakers in various rooms around the house. We'll look at the Sony surround sound system. When he clicks on this system, this speaker, he sees that all he has allowed access to is the volume control here. And so all he's able to do is control the volume for this speaker via this Google Home application. If he clicks on the three dots at the top here, he sees that there's only some device information, nothing very relevant to him as the end user or useful for him as the end user. We see in this page that there's actually a lot more APIs available to be called to provide more control over the application. We can get current radio frequency, we can turn it on and off, we can change the sound field, and a couple other things that we won't go through. We'll look at another situation. The point I'm showing you this is because even though there are so many other APIs that we can call, in the previous slide we saw that Google Home only offers volume control. We'll look at another example. We'll look at the Sonos Arc. This one, even worse. When he clicks on the Arc speaker, he only sees a couple of things that he can change. A name, he can change which house it's at and which room inside that house it's currently located at. But if we look at its APIs, we see that there are actually a lot more APIs available for that Sonos speaker, but yet there's none of these are supported on the Google application. We'll talk about why this is in the next slide. The reason that you cannot access all of the APIs shown in previous two examples is because that Google Cloud only has limited device knowledge. Since all the device knowledge is managed and stored on the cloud, when an application wants to send a request to an IoT device, they are at the mercy of what's supported by the cloud. In this instance, if and when there is an IoT device that is non-Google or non-Google manufactured or non-Google supported, they will only have limited access to device functionalities. By running as much as possible at the edge, we can enable full device functionalities. User application will not be at the mercy of a central cloud. It can access fully supported libraries from OpenHAB, which is the leading source of IoT device automation software for home. For instance, in this setup, we can see a router working with a device with the same capabilities as a Raspberry Pi over here. And it's running OpenHAB. The combination of these two devices can be considered as the gateway-like device that has the potential to handle requests and respond similar to a cloud. Mimik EdgeEngine and its microservices unlock this potential. Once this potential is unlocked, Mimik Edge-enabled applications can discover, connect, and communicate with devices in IoT cluster directly in a peer-to-peer fashion. If Mimik Edge-enabled application is not on local network where all the edge processing is taking place, they can request secure access from cloud via 3G, 4G, LTE, and 5G. So if you're not on the local network here, you ask the cloud, hey, can I get a secure token or a secure a key to access all the access inside the devices that are inside the home Wi-Fi network. And from there, you have a secure connection and you can communicate with all the IoT devices, regardless of their brand, manufacturer, or anything like that, because all of the augmented device knowledge is kept over here. And so a combination of Mimik Edge and microservices, plus a device like a Raspberry Pi that has processing power, RAM, and some general capabilities, running OpenHAB, you can achieve this architecture as edge processing. And of course, both user and other user applications also have Mimik Edge and microservices. Now we'll look at a use case, which is controlling a thermostat, and how to leverage microservice mesh capability to provide more granular control by using device native interface. So in this demo, what you're going to see is this. User's homeowner's device will open a Mimik application and they will get a list of items, which is items that allow you to control different functionalities of the thermostat. We'll use the application to directly communicate to the thermostat via this path. So we'll use the network provided by the router, and from the router we'll connect to a device that is running Mimik Edge Mimik Edge Engine, its microservices, and it's running OpenHAB with the library to support the commands that are used to control the thermostat. We have a Windows machine. In previous slides, we showed that you would need something like a Raspberry Pi to work in tandem with a router to be that one gateway device. Well, in this instance, we're using a Windows machine in place of that Raspberry Pi. So this Windows machine is running OpenHAB, and right now I have an IP camera connected to it, and it's pointing to a thermostat that you see here. On the right side, we have a homeowner's smartphone, smart tablet that you see on the side here. So we'll now go into the shared home. This is the edge-enabled shared home, smart home application, and the homeowner will log in. So once they are logged in, they will see a page full of the items that were mentioned in previous slides. So some of these items are for controlling or calling APIs that control this thermostat that you see here. So I want you to pay attention to the 21 and the 18 because I'm going to go into the application, and those are corresponding to the heating set point and the cooling set point. So first we'll change the cooling set point here. We'll go on the application, and let's say we'll change it to 20. And we'll press send. So keep your eye on the 21. It will change to 20. So that you saw it change to 20. So now we know that this application is correctly communicating with thermostat. We'll do another one. We'll go to heating set point, Change it to 17 maybe. Can't go that high. Keep your eye on the 18. We see it change to 17. We'll do it one more time just to be sure that everyone sees. We'll change it back to 18. Keep your eye on the 17. It changes to 18. So we have confirmed that all the processing at the edge is happening correctly. Now we'll take a look at the technical details behind the demo you just witnessed. So here is the home gateway that we saw, which is what's running on my Windows OS. It has mimik edgeEngine, it has OpenHAB, and it has a mimik microservice called mitem. So OpenHAB is used to communicate with the native interfaces of the thermostat, and we can have another device like a smart lock. And from there, we can go and see what two different networks that we're in. So we have the home network on the bottom of the dashed orange red line, and above that we have 3G, 4G, LTE, and 5G, which is outside of the home network. So each device, or the device, no matter where they are, if they're on the home local network or if they're on a network outside outside the home, mimik edgeEngine is able to discover the edgeEngine of the home network on Windows OS, and this provides the discovery and the connection. Now we have the microservices, which creates the microservice mesh, and mitem here is the service mesh that provides the service mesh using microservices. So this here is how that demo was achieved. So the items that you saw on the application were coming from the mitem microservice, and the mitem microservice was fetching those items from OpenHAB. So those are the items that allow me to change the cooling set point and the heating set point. So that's directly coming from the native interface to OpenHAB, and OpenHAB is feeding those items to mitem, and mitem is then passing along those items to the mitem of a guest Android, which can be outside the home network or inside the home network, and also it's doing the exact same thing for the homeowner's iPhone or any other type of device that's inside the local house network. Now we will look at the Passkey use case 2, and this is sharing the control of an IoT device with others. In this case, we will be sharing the rights to a smart switch. So in this setup, very similar to the previous setup, we will see that a guest will need access to the smart switch. So the homeowner here will issue a passkey. This passkey will be sent via the local network to the cloud to the guest application, which is also the same application as the homeowner, which has edgeEngine microservice, and so does the guest smartphone has edgeEngine and microservice, and they have this secure passkey. So when they get to the home network, so let's say this is an Airbnb situation, you own a property and you have a couple guests coming over to the property and they want to stay for a while, you want to give them access to the IoT devices for a certain period of time. So you can think of this demo as explaining how that would work with Mimik solution. So once that guest has that passkey, when they enter the home, they will use that passkey and they will be granted access to the device, in my situation, the Windows OS that has OpenHAB and the augmented device knowledge, including edgeEngine and the microservices. And when they get to the house or property and they use that key, now they are able to communicate with the smart switch, discover the smart switch, connect to it, and communicate with it with its full device functionalities. Now we'll jump into a demo. So similar to the previous setup, we have the homeowner's tablet here, and from the IP camera feed, I have changed out the thermostat to show a lamp. This lamp is connected to a smart switch. So when I turn the smart switch on and off, you will see this lamp go from off to on and vice versa. So now we want to talk about sharing. So in order to talk about sharing, I need to bring in the guest device. So I'll bring in the guest device here. I'll cover the lamp for a little while now. And so we'll look at the shared home application. We'll log in just like how the homeowner logged into the application. And we'll go into our shared devices. So right now there's nothing shared to us, so we have no control over any IoT device. But on the homeowner's tablet, we'll go look at this power item that you see over here. So with this power item, if I click the share button on the side, I'll get a list of the people that I can share this to. So you can think of this as, oh, when a guest accepts their invitation or their booking for your Airbnb that you have the property for, you'll see a list of who should have rights for the upcoming property. And so this will be a list like this. So in this case, I have one person, I have one guest, and it's this guest right here. So if I click on this guest, I should get a notification at the bottom saying that the power plug was shared to that user. So if I do a quick now, I will cover the homeowner's device so you can see the lamp. So now we're just looking at the guest device here. If we do a quick refresh, we see that power item show up here. So if I click on this power item, I will get a switch. And now keep your eye on the lamp here. So if I switch it, it's off, so the lamp's currently off. So now if I switch it on, it switches the power switch on, which thus turns on the lamp here. And so I can exactly turn it off again, and it will turn off the smart switch, which thus turns off the lamp. And I can also show that this didn't affect the homeowner at all. If I just close this for a second and I go back to all the items that are provided, I still see the power switch here, and as usual, I can turn it on. It will turn on the power switch, which turns on the lamp here, and I can turn it off again, which turns it off. Now we'll look at use case 3, hand gesture and fall detection. How to use microservice mesh capability and AI to enable IoT orchestration. So in this setup, very similar to the previous setup, but in this setup, we have the feed of the IP camera, which I've shown in previous demos before. But in this situation, we're going to use the feed of the IP camera, and we're going to do some processing on the feed. And on this feed, we're going to use edgeEngine and microservices and OpenHab. And on top of that, we have AI to be able to decipher the feed and look for certain situations inside the feed. And in this situation, we're going to do hand gesture first, and then we'll do fall detection. Before, we have the homeowner's application over here, and we have the IP camera feed that's pointed at me right now. So now I will keep your eye on this tab over here, incoming beams. We will see a notification at the top here when the AI that's running on the Windows machine detects that I have raised my hand. So I will face the camera. I will raise my hand. I'll do it a couple times. Raise my hand again. And I'll raise my hand one more time. So the AI should have picked that up. So in a few moments here, we will see a notification at the top. There should be a little new circle. And when that shows up, we'll go to it. So that circle showed up. Now we'll go into there and we see that we have a new item. If I click on this new item here and play it, it is a video clip of me that's raising my hand, which is exactly what I recorded. So the AI is working and it's detecting properly. Same thing, keep your eye on the top right and we got the notification. So if we go into the notification, we have a new item and we open it, we see that it's a quick clip of me falling. Play it one more time, it's pretty fast. There it is. Same setup as before. Now we'll look at the technical details of the two demos that you just saw. So similar to the previous setup, we have an IP camera with a native interface, and we're taking the feed from that camera and we're passing it into the home gateway. But inside the home gateway, which is running on the Windows, we have a couple of extra things compared to Passkey and thermostat that you saw earlier. So here we're passing the feed into fall hand gesture detection agent here. So this is the green box in tandem with mmodel share, which is another microservice, and app logic serverless agent is the Edge AI package that pretty much, in summary, does the detection. So when I raised my hand or when I fell, these three is the application that's doing the detection on the video feed. So when that detection takes place, it's happening among these three. And then when I change the model from hand to fall to detect one thing over the other, this happens in model share. And this is all running on top of the edgeEngine. And then we have another microservice called SuperDrive and another one called mbeam, and same thing on the iOS and the Android. You saw it on the Android, but it would be the same on iOS as well. So this means, so again, same. We have external network, home network, local network, and we have 3G, 4G, LTE, 5G on the outside. We used edgeEngine, like you saw before, to do the discovery and the connection amongst all the devices, Windows OS, iOS, and Android. And we use the microservices, mSuperDrive, mbeam, that are also on the Android and the iOS device to receive that video. So when the detection takes place, the Edge AI detects the video and creates that short clip. It passes it to the SuperDrive and mbeam microservices, and these microservices, it's on their job using the information provided by the edgeEngine to send that video and the notification along with it to whichever device that has rights to see this video. In this situation, it was an Android device, but it wasn't a guest Android. It was a homeowner's Android, and they were able to open that video and view it on their smartphone. So this has been Mimik, a home IoT solution. Thank you for watching.